This is second video of micro in a system programming. In this video we will see about advanced micro facilities like micro calls within the micro, nested micro calls, that is. Then next is micro instruction defining a micro, conditional micro expansion, expansion time variable. There are two types of expansion time variable. One is local variable and second one is local is what? Environmental variable, and second is global variable. And last point is expansion time loops. In previous part, that is in part 1, we had discussion about what is micro, keywords or parameters, three types of parameters in the micro. Just have a quick revision about the previous part, then we'll see the advanced micro facility. So firstly, see what is a micro. Micro is nothing but the set of instruction, or instruction is a notational convenience for a programmer. It is a single and abbreviation used for a group of instruction. This is nothing but a micro. Now see what microprocessor do. Microprocessor take a source code with a micro, then it recognizes the micro definition. After recognizing a micro definition, it saves the definition and it defines the micro calls. Whenever micro calls is there, it expands the micro call. See the example. We have given a source code with a micro, then microprocessor removes this micro with the help of micro definition and expanded code without a micro, that is given as an input to the compiler or a assembler. This is a task of a microprocessor. Now see what is the syntax of micro definition. First keyword micro is there, that means it defines the micro, and after that name of micro is given, and after name of micro list of parameters is given. So these are nothing but the formal parameters. And at last end is a keyword for showing the end of micro statement, and in between micro and end micro definition is there. See the example here, micro keyword is there and after micro keyword adds is there. This adds is nothing but the name of micro. Then arguments, formal arguments, argument 1, argument 2 and argument 3 are given. And this LAST is nothing but the definition of micro, and lastly is what? MN, which shows the end of micro. Now see expansion of a micro call. In the left hand side, source code with a micro definition and call is given. Micro adds, LAST is a definition of this adds, and MN is there. Always remember, program start its execution from this start pseudocode. So here on right hand side, see on right hand side we are seeing the process code after micro expansion. So it will start from the start pseudocode, start BALR, using these are the pseudocode which you have to write down as it is. After that adds is nothing but your micro. Instead of writing this adds, you have to write the definition of the micro. So what is the definition that micro contains? This LAST. So you have to write down LAST, and this data 1, data 2 and data 3. This is nothing but the actual parameter that you have to pass. So argument 1 is equals to data 1, argument 2 is equals to data 2 and argument 3 is equals to data 3 that you have to write down. And rest of the things, this you have to write down as it is. So this is nothing but the micro expansion. This is second example of micro expansion. If you want detailed explanation, then you can refer the previous video, that is micro part 1. Now see, there are three types of parameters. First is positional formal argument, second is keyword argument, and third one is default argument. Positional formal argument are stick with their position. So argument 1 is equals to data 1, argument 2 is nothing but the data 2, and argument 3 is nothing but the data 3. So what is the formal parameter which are available in the given definition? Argument 1, argument 2 and argument 3. And in micro call, the actual values of the actual values of the parameter are data 1, data 2 and data 3. Now see the keyword argument. So here in keyword argument, after keyword equals to sign is here. So first argument is sorry, arg1 equals to, second is arg2, third is arg3. So this is nothing but the keyword type of argument. Now see, in microcall, argument 1 is equals to data 1, argument 2 is equals to data 2 and argument 3 is equals to data 3 is given. So you can change the position of this actual argument. This is nothing but the keyword argument. Now see, firstly argument 2 is written. What is the value of argument 2? Is equals to data 2. So argument 2 is equals to data 2 is written. Argument 3 is equals to data 3, so that we can say the position of the keyword that you can change. They are not stick with their position. This is nothing but the keyword argument. Now see, what are the formal parameters which are present here? Argument 1, argument 2 and argument 3. Value of argument 1 is data 1, or actual parameter of argument 1 is data 1, argument 2 is data 2, argument 3 is data 3. Last one is default argument. So here argument 1, 2 and 3, these are the default, these are the formal parameters. Now in microcall, argument 1 is equals to d1 is given, argument 2 is equals to d2 is given. In second case, argument 2 is equals to d2, argument 1 is equals to d1 is given. That means you can override the default value. This is nothing but the default argument. Now see, what are the formal parameters that are present in the given example and what is the value. Argument 1 is data 1, argument 2 is data 2, argument 3 is data 3. And now this is example of micro with mixed parameter list. Now see, what is a micro and what is a subroutine. Micro means what? Every microcall is replaced by its definition whenever microcall is there. And after expansion of a micro, length increases, so memory is required. And in micro, context switching is not there, so that processing time is less as compared to subroutine. What is a subroutine? Subroutine is also known as a function. Every subroutine call transfer control to the first instruction of a called subroutine, and after a processing subroutine, program size remains same because the control is transferred to its definition, but its definition is not replaced by its call. So we can say the program size remain the same. And last one is what? Here context switching is there, so processing time is increased in case of subroutine. This is the difference between micro and subroutine. Now see, what are the advanced micro facilities that we have to see. First is nested micro calls, that is nothing but micro within a micro, micro instruction defining a macros, then conditional micro expansion, expansion time variable and expansion time loops that we will see here. Now see, first is what? Nested micro calls or micro calls within a micro. So we have given one example which contains micro definition of one micro may generate call to another micro is called as nested micro. Now see, here micro keyword is there and name of micro is test, and here the end of this test micro, and here another example is given, that is micro name of the micro is adds, and here end of this adds micro. So this is nothing but the micros example. Now see the test. In this adds is what? Your second micro. In this adds, the first micro, that is test, is used. That is what? Micro is used inside a micro. That is nothing but the next nested micro calls. After second nested micro call is there and emit is there. Now see the source code. Here first is what? Micro keyword, then name of micro is test. This LEST is nothing but the definition of this test. Then here end of the test micro. Here another micro name, another micro definition is started. The name of second micro is what? Adds. Inside this adds, test micro is there. Again second test is there. After that comparison is there, and the end of the adds micro is there. Now see how to expand this nested micro calls. Now see, here adds is there. Here A, B, C, which are the actual argument of this micro. So expansion of this adds is what? Adds contains the test, right? So here is what? Test. First is what you have to write down the previous code as it is, then test A, test B, and comp cmp 1,c that you have to write, expand in first step. That means replace this micro call with the actual argument only. In second level of a source code, you have to replace the definition of micro. That means in next level you have to expand the nested micro. What is the definition of test? This is a test which contain last. So here is what last. Second is what, again in second case also last, just you have to replace the actual parameter by the a and b value, and rest of the things you have to write down as it is. L1 comma, here argument is there, so instead of this arg you have to write down a, then 1 comma equals lateral is there, then st 1 comma argument is there. What is argument here? A. Then L1 comma B, A1 comma equals to F1 and ST, that you have to write down, and rest of the things as it is. This is what expansion of micro calls. This is first expansion of test micro, and this is second expansion of test micro. Now see what is micro instruction defining a micro. Micro definition may defines another micro. For example, here micro is there, then define is a name of micro, then micro again this define micro content another micro, that is sub micro. So here is sub, C N O P B A L D C L B A L R M and is there. So here this is called as a inner micro. The ampersand sub is nothing but the inner micro, and this define is nothing but the outer micro. This is what micro instruction defining a micros. Now see what is the conditional micro expansion. The keyword AIF and AGO which are used for the conditional micro expansion. Now let's consider the example. Loop 1 A1 comma A1 A2 comma A2 A3 comma A3, then another loop is there, then third loop is there, then A1 A2 is there. Now see what is what you have to do. First is what, here loop 1 contain 3 variables, that is a or 3 parameters A1 A2 A3. Loop 2 contains 2 variables A3 A2. Loop 3 contains 1 variable, that is A1. So AIF and AGO which denotes the conditional micro expansion. So here start from the loop 1. Loop 1 contain A, so this is your loop. Okay, A1 comma AR1. So AR1 is nothing but your formal argument which you have to replace by actual argument. So here 1 comma A1, 2 comma A2, 3 comma A3. So here is expanded source code. Now see the loop 2. What is loop 2 contains? Loop 2 contains 2 variables or 2 formal parameters. So what are they? A3 and A2. So A1 comma A3, A1 2 comma A2, that you have to write down. Loop 3 contains 1 variable or 1 parameter. So A comma A1 comma A1, that you have to write down, and rest of the things you have to write down as it is. This is nothing but the conditional micro expansion. Now see the expansion time variable. Expansion time variable can only be used during expansion of micro calls. There are two types of expansion time variable. One is local, that is LCL, used during particular micro call, and second is global, which are used within a program and can be used in any micro which has declaration for it. Syntax is what? LCL, which denotes the local micro, and GBL, which denotes the global micro. Now if you want to change the value of the variable, in that case you can use the statement, that is set, or set, we can say set is a keyword for changing a micro variable value. Now see one example. So here micro is a keyword for defining a micro, then test is a name of micro, then LCL is there, that means here it is a local variable. Then set is there, that means you have to change the value of the local variable by 1, then you have to increment this value, then again you have to change the variable, that is current value plus 1, then decrement the value, then end of the micro is there. This is nothing but the expansion time variable. Example. Now see, this is an example of conditional expansion together. Now see what is the design of 2-pass microprocessor. For designing of 2-pass microprocessor, 2 passes are there. So see what is the purpose of first pass. Purpose of first pass. First is what? It recognizes the micro definition. After recognizing the micro definition, it stores the micro instruction definition. Now see what is the purpose of pass 2. It recognizes the microcalls and expands the microcalls. This is a use, or this is a pass 2. Now see what are the data structure which are used in pass 1 and pass 2. Pass 1 contains the source program with a micro definition and microcalls, then output file without a micro definition and with a microcalls that you have to create or you have to generate. Then it contains the micro definition table, that is MDT table, micro name table means MNT table, argument list array, that is ALA, micro definition table counter, that is MDTC, and finally micro name table counter, that is MNTC. So these are the data structure which are used in pass 1 of a micro. And pass 2 data structure contains the input file without a micro definition and with a microcall, expanded output file without a micro definition and microcalls, MDT table which is created by pass 1, MNT table created by pass 1, ALA list, and micro definition table pointer. These are the data structure which are used in pass 2. Now we will see the format of all this data structure. First is what? Argument list array, which contains the index, formal arguments and actual arguments. So these 3 columns which are present in argument list array: index, formal argument and actual argument. Next is what? Micro definition table, that is MDT, which contains the index and micro definition instruction. The next is micro name table. It contains 3 columns. First is index, second is micro name, and third is MDT index, that is micro definition index, micro definition table index. So this is a micro name table. Next is that MDT, MNT, all this contains the integer variables. Now see, you have given this example that you have to solve with the help of micro. So here is micro source code with a micro definition call is given. Micro is there, so adds is nothing but the name of micro that you have to include in micro definition table. So this add is included into this MDT table. Then arguments are arg1, arg2 that you have to include into argument list array. Then after that, here is your micro name table. Micro name is what? Your adds, and micro definition table contains the definition of table which contains adds LA, all definition, and here you have to start indexing from 1, 2 and 3. Micro name means here in this given program only one micro is there and that name of micro is add. So here only one entry is present in micro name table. Index is 1, name of micro is adds, and micro definition table. That means you have to put this value from this MDT table. Here is index 1 which contains adds, argument 1, argument 2, and after that you have to write down the definition of adds. L, here on this line L contains, here is A instruction is there. So from this MDT table the index value of this MDT is 1. So here micro name 1 and micro name is adds which contains MDT index as a 1. Now see the solved example. see the example here, adds that you have to include into micro name table. Okay, and index is 1. Now see what is micro. This index count is 1, that I will tell later. So now see the micro definition table. So what is a micro definition which is present in the given example? Here is adds argument 1, argument 2. So here is write down adds argument 1 to here. Then what is the definition of that adds that we have seen previous? LA. Okay. So here write down LA. 1 comma argument 1 is there. So before getting the actual value, you can write a #1, #2 for the given formal values, and then amend is there. So what is the adds? Adds is nothing but the name of micro. And what is the index of this adds? This is 1. So MGT index for this MNT table is 1, that you have to write down. Now see the argument list array. Index is 1. What is the formal argument? 1. What is the formal argument? That is arg1. Second formal argument is arg2. This is the output after processing of pass1. So here is #1 which contains argument 1, #2 which contains the argument 2. Now see what happened in pass2. After processing for pass2, you have to write down the actual values of the given parameter. So data 1 and data 2 you have to write down into ALA table. So add one more column for pass2. What is the actual value for argument 1? That is data 1, and for argument 2 is data 2. Okay, that's it. #1 refer for the index 1 and #2 refer for the index 2.